All right. Here we got intro to inequalities. Okay. Um, so with a regular equation, we use an equal sign to show that both sides are equal, right? But for inequalities, we have sides that may not necessarily be equal. Okay. So there's a few different signs for that: greater than, or equal to, which means it can be greater than, or it can be the same as. Okay. Less than, or equal to. Same thing. It can be less than or the same as. So here we're just going to use very, very basic comparison stuff. Again, so here 4 would be less than 9, right? So if I find my less than sign, I have 4 less than 9, which works out perfectly. Here, sometimes this can throw us off. Okay, 0.5, 0.45, or 0.45 rather. I'm going to add a 0 right there to make it a little bit more easy for me. Pull this down a little bit so you can see the greater than sign. So I know that 50 cents is greater than 45 cents. So that's the sign I'm going to use. 50 cents is greater than 45 cents. Now this thing here, this one's a little bit interesting because sometimes some of us still struggle a little bit with our positive and negative numbers. All right, so let's say we made a number line. Okay. We're trying to figure out which is greater or less than or equal to. So, -3 is going to continue to go further and further and further and further away from 0. The closer you are to 0, or as a negative number, the closer you are to 0, the greater your number is. Once you go beyond 0, then obviously it's a different story. But in this case, a lot of people might see -3 as being the greater number. That is not true. -3 is less than -2 because it's furthest back. It's further than -2 on the number line. I'm going to do the same thing here that I did with the second one. I'm going to add a 0 at the end. So now I'm just looking at it as money, which is less than $1.04 is less than $1.40. Therefore, that's what I would write. You're just comparing. That's all you're doing is comparing. All right. For inequalities, okay, you want to use the variable as your starting point always. Okay. And we'll talk about what that looks like, what that sounds like in a little bit. When reading an inequality statement, for example, it's not that 6 is less than or equal to x. That can be written as x is greater than or equal to 6. You always want to start from the variable. Now, this is important, right? Because it says a value can be substituted to determine if the inequality is correct. Now, this can only really happen if they've given you a value here. So instead of x, I'll write 5 plus 6, they say is greater than 11. Well, 5 plus 6 is 11. Is 11 greater than itself? No. So this particular statement would be a false statement, okay? Looking at the second one, they're saying 7x, remember when they're stuck together, it's 7 times x, is less than 45. Well, if x equals 6, then let's plug it in. We have 7 times 6 is less than 45. 7 times 6 is 42. And 42, is definitely less than 45. So this particular statement is true. And we have a few of those, so we're going to talk about that, okay? All right, cool. So k plus 8 is greater than or equal to 19. Well, if k is 11, then we'll write 11 plus 8 is greater than or equal to 19. 11 plus 8 is 19. This statement is true not because 19 is greater than 19, but because 19 is equal to 19. Remember, our signs: greater than or equal to, less than or equal to. Okay, it doesn't have to be one or the other. So in this particular case, for number 1, this is a true statement. All right, here we have 12 is greater than f. Well, okay, f is 3. 12 is greater than 3. So this is also a true statement. Okay, here we go. C minus 12 is greater than 30. C, they say, is 13. So we're going to replace C with 13. 13 minus 12, they say, is greater than 30. 13 minus 12 is 1. Is 1 greater than 30? Nah. So that's false. Let's keep going. Here they're saying 16 is less than b minus 8. All right. Well, let's rewrite this. B is 22 minus 8. Well, what's 22 minus 8? I guess that's a good question, right? Let's do that real quick. 22 minus 8. Borrow. That is a 15. Oh, let's see. Is 16? No, wait, isn't that 14? Yeah, my bad, 14. Either way, is 16 less than 14? No. So this is also a false statement. All right, let's keep on keeping on. We have x divided by 12 is less than or equal to 3. Well, if x is 48, let's plug it in. Uh, 48 divided by 12 is 4. Is 4 less than or equal to 3? No, not even close. That is also a false statement. Let's check this last one out. Negative 10 plus p is less than or equal to 20 if p equals 15. Okay, well, plus 15 less than or equal to 20. All right. Well, again, you want to look at these two numbers here and see which one has the greater absolute value. 15 does, because it's furthest from 0. So our answer is going to be positive. This is positive 15 minus 10, which gives us 5. 5 is less than 20. It's not equal, but it is less than. Therefore, this statement is also true. Yeah, inequalities are not super duper hard per se. But again, you want to get into a habit of reading it from the variable. Okay, also part of these inequalities are when we plot, when we graph, when it's just greater than or less than, we plot with an open circle. Okay, if it's or equal to, we plot with a closed circle. Okay, so let's look at this. It says k is greater than 11. Okay, so k is going to be anything greater than 11. F is less than or equal to 12. Less than or equal. So again, because it's less than or equal, I'm closing my circle. If it's less than or equal, then the values that are less than 12 go in this direction. Do not fall into the habit or the trap of seeing this as your directional arrow. That's why we always read from the variable. Variable f. F can be any number, either equal to 12 or less than 12. This is the number that would be equal to every other number would be less than. But notice how this is pointing to the right. This is moving to the left. Don't fall for that trap, y'all. All right, D is less than 6. So again, D represents every single value less than 6. C is less than 25. Perfect. C is going to represent every value less than 25. Now this one here, B, is greater than or equal to 0. Greater than or equal to is a closed circle. And again, greater than or equal to 0. Okay? Just because this is pointing that way doesn't mean that's where the arrow goes. The B is a variable that can be equal to 0 or represent any number greater than 0. All those numbers greater than 0 are going to go this way, not the opposite way. Okay? X is greater than or equal to 4.5. Okay. 4.5 is going to be right here in the middle. We have a closed circle because it's greater than or equal to. So if it's equal to 4.5, it's right there in the middle, or it can be greater than. Therefore, it moves in that direction. Okay. Let's keep on going. When we're trying to figure out, sorry, I had a pen in my mouth. When we're trying to figure out how to